Hi, and hope you are doing well. I am Jadi. This is Geeking with Jadi, or Geeking Jadi, I'm not sure. And we want to do the coolest thing ever today, this hour or something. We want to maybe write our own Unix command for the users. Now it's on normal brush. Okay, what's the story? I was working on the users command for core utils on OpenBSD. It is working everywhere. utils is a rewrite of the core utils like ls, users, who, cp, echo, and everything you see in a Unix world, and Mac and Linux. Those are Unix-like systems. Rewrite in Rust. And I noticed that the one in the OpenBSD is not working, the users. Started digging into it. OpenBSD is fun, maybe the secure, most secure operating system in the world. Very cool Unix from old times. We had the AT&T Unix, then we had BSDs, then we had FreeBSD and NetBSD. Based on some arguments, disagreements, NetBSD forked as an OpenBSD, and nowadays it's a very active project, very cool, very nice, and claims. And after checking, experts can agree mostly that it's one of the most secure operating systems. There are arguments, but anyway, that's not our story. I saw that the users command is not working there and started to investigate, worked on it, got a very good understanding of why, created the command, created a few libraries to let the command work smoothly on different environments, 32 bits, 64 bits, different times and everything. But I thought it's very cool to show you on the deepest level possible, maybe. You can always go deeper, but very deeply show you how the users command work, and you may be able to write your own users. Fun fact, only 14 megabytes of memory is used by OpenBSD when booted up with few services. So, users command, you may know it. We mostly use the who, but users is kind of the same, less information. It's more simple for scripting. Users will show the users logged into this system. For example, if I'm on this system and say SSH to the localhost, I had to go with root, so it's a different users. I will go here to type the password. Just kidding, it's not, just kidding, it's not an important password because it's a virtual machine. So, now if I do users, Jadi and root are there. I was Jadi, I logged in again as root, so now two users are here. I can exit. But why this was not working? Let's first check the manual. Manual is on the OpenBSD is one of the great resources. Some people claim that you don't need internet when you have the OpenBSD manuals on OpenBSD. It has all the information you need. Sometimes people create viral videos in OpenBSD community, which is cannot be viral in other Unix, but they try to live without internet and only going forward with manuals. Anyway, users, list current users. Synopsis is users only. Users listed login names of users currently on the system in sorted order, space separated on a single line. And this is the file it uses. Appeared on BSD 3. Everything I told you about FreeBSD, they started from 4.4 or something. This is the file we need. So, nothing fancy here, but it uses this file. Why it was not working on OpenBSD? Because this UTMP file comes from the beginning days of the Unix from AT&T. I think even version 1 maybe. We can check later. You are on OpenBSD, so you should be able to check. Let's try. Man UTMP. If you go to the end, it says it appeared on version 1 AT&T. Super cool. Where is it? Why is this happening? The point is, problems happen. You should be able to solve them. So this started here. UTMP file format, UTMP. Later, another kind of a standard, not official standard, came from POSIX. It was called UTMPX. Practically all Unixes and Unix-like systems are using UTMPX nowadays. It has more information, but OpenBSD decided to stay on UTMP. I had a quick discussion with them. They said because there is nothing in UTMPX that we need. UTMP has whatever we need. We have the who command, we have the last command, we have the users command, W command, uptime command, all of them are working. UTMPX does not offer anything we need. Sane, logical enough. Not logical, rational. So, I mean, that was not a correct word to use. Anyway, so OpenBSD is one of the fewest or only major operating system which uses, if you can call OpenBSD major, which uses the UTMP. That's why on utils, the rewrite of the core utils, these kind of commands like users doesn't work on OpenBSD. I said I will add it. I did, and now I'm showing you how. So we had the users uses this file, and we need to understand how this file works. Let's have a quick look first. If I do an ls ltrh var run utmp, it says, okay, this is a 6.8 kilobyte file. Large enough. Dated today, so it's being updated. If I do file, which shows if it understands what the file is. Var run utmp says, okay, so data file. Not much information. You cannot cat these files, these kind of files. That's nice. I would say cat var run utmp. It's something like this, not very beautiful, but you can see some information. I can see Juddy, but some garbage here, be able to solve your problems. So Juddy is here. This is the line. What is this? Still not good. But you are on, you can do OD. OD, octal dump, with characters, show the characters you know. What file? Var run utmp. Much nicer. OD will show you the octal dump, the equivalent of the every byte it sees. With C, it will translate the characters it understands. So this is the sector, so beginning of the file, this location, this location. There is a star here, which means this continues for many lines up to here. So to start, we had 0, 0, 0. Please note, this is the byte 0, not the character 0. This is the character 0. There is no trailing backslash. So this should be in ASCII, not 32, 41 or something. So 0, 0, 0, 0, 0, 0, 0, 0, 0 up to here. Then we have TTYC0. This is the connection for this user. Then some zeros. Then Juddy, me. Then some zeros. A lot of zeros. Up to here. Not a lot. Some zeros. Then we have this X361FF. Lowercase, uppercase. We cannot understand, but we understood somehow. But you are on OpenBSD and they claim to have the best manuals. So man UTMP. This is where we are following how users command work and will try to write our own. You will try. I will just show you how. Now we understood that users will go to var run users and manual of var run UTMP, and manual of the UTMP says these three files uses the login records. We are on page or book 5 of the manuals, file formats, describing the file formats. It includes in C a header and says the UTMPH file declares the structure used to record information about current users in UTMP file, logins and logouts in WTMP file, and last logins in the last log file. Cool. The timestamp of date change, shutdown, and reboots are also logged in UTMP. So we have 3 files. UTMP for current users, WTMP for logins and logouts, reboots and shutdowns, and time changes. Cool. And last log for the last logins. Nice. Now you know when you log in a Linux or Unix machine or your Mac, it says last login this time. It's recorded in last log. Description. WTMP can grow rapidly because it saves all the logins. And these are the structures. This is cool. It defines 3 paths. Paths of UTMP is var run UTMP. This is the source code of OpenBSD, also in many other Unixes. Then it defines 3 constants. UT name size is 32. Nice. Line size is 8. Nice. Host size is 256. These are 3 constants. And says, okay, structure of a UTMP is characters, an array called UTLine, line size. Line size was 8. So each record of a UTMP file is line size first, which was 8. Then this is the line where the user is connected from. Is it a USB connection? Is it a telnet connection? Direct console, teletype, whatever we have. Then the name size, it was 32. Here it's defined. So the username, and then host size, which is 256 bytes, and it's host. If it's remote, what is the host name the user is connected from? And then a UT time, the size of the time on your system. Here I think it's 32. And that's a problem with the next problem with time. Another story. So this is every UTMP structure in var run UTMP. So if you have 3 users, you have 3 of these data blocks there. Now you can understand more what is happening there. If you want to know how this is populated, you can continue reading, you can check other commands. But the users command, you know it deeply now. This was our OD. Each one of these is the structure. Now everything is 0 in the first one. So 8 plus 32 plus 256. Whatever this is, we have all zeros here up to here. These are octal. This is octal dump. The next field starts here. First, 8 bytes will show me the line. 1, 2, 3, 4, 5, 6, 7, 8. It's a C string. Ends in byte 0. This is the character 0. So this user is connected from TTY C0. The next 32 bytes is the name. Okay, JADI, then a lot of zeros as we know. And then the host name, lots of other zeros because this is a direct terminal, I'm connected, there is no host name. So I will go up to here, then the timestamp. So Jadi is connected from this terminal without any host name with this timestamp, which is a binary, you should convert it. This is the epoch time. I start from 1, 1, 90, 70. This is 0. Every second passes, this goes 1 up. So whatever this is, if you convert it to the numbers, you have the number of seconds passed from this date, which can be converted to the date. Then what we have, nothing else. Some of them do not have the username, just some data. Like this one, TTYP, blah, blah, but nothing. Okay, no username. So if I do with users, now you know where this Jadi comes from. If I do who, again, you know what is happening. This is showing just more information. Jadi, the line, the time. Super cool. Now you know deeply how Unix works. Why not have a look to the source? Ha! I have the OpenBSD source here. Please remember, I'm talking about UTMP, which is an older format, which is the classic format, not to blame anyone. And they don't need to use UTMPX. Here you can go to the source. Normally they don't moderate the project, manage the project from GitHub, but this is a mirror. So it has all the information and easier to browse than SVN. Here on the source, I can go to the user bin because it's binary for users. And here, obviously, I can go to the user's command. Never use search when you can scroll. Scroll the whole internet, but never search. Just kidding. Users 1 is the manual. The new format is converts to the manual. User C is the C file, and you can see it's only one file, 3.2 kilobytes with all these headers. What I do always is scroll it once. It's small. Now you are brave to read it. It starts with some defining general types. I'm repeating, this is OpenBSD. You are reading the source code of the most secure operating system alive. Ever. Operational operating system, because obviously you can have more secure operating system, but you cannot use them in a daily basis. Define some headers, includes UTMPH, you saw it on the help. Defines a name buff. I'm not going to describe it line by line because it's not the target of this project, but I will go through it once. It defines a name buff. It's a buffer to read. Name count and name max. How many names I can keep. And count of the name I have. I will describe why it's a little bit strange. Then it defines this struct. Now you have the UTMP. It does some OpenBSD stuff in the beginning. Tries to unveil path UTMP with R. Pledges it. Then checks the argument. If you have more than needed arguments, it gives an error and says, okay, the usage is this. And then it reopens this. If fails, it says I can't open. This is no reach because we have tested this above, but this is the main part which happens. It says while you can read data, read UTMP, how much bytes, the size of UTMP, now you know. Read this much data from that file into UTMP while you can. If you can't, we've reached the end of it. Then, if the UTMP you read has UT name, save the UT name. If you were working with Rust, Python, whatever, you could say users equal an array, add the name to the array. But in C, you cannot do this. In C, you have to manage your memory. And you have to create a buffer for this. A novice programmer might do, okay, how many names we may have? Thousands. Nobody is going to have more than thousands. So we will define a memory slot for 1,000 users and save the users there. Not very nice. Why? Obviously, you may have more than 1,000 users. You may want to run OpenBSD on a very, very small IoT device with limited memory. And you're wasting this much memory just because you may need it. The better way is this one. If n count is larger or equal to n max, they both started at 0, create memory space for another 32 memory space. Every name could have been 32 bytes. So create one more space. Create the buffer for it, allocate the memory for it, and copy it over the names. So practically each time you have a new user, it opens the space and extends the memory it is using. So you're not wasting anything and you can have unlimited users as long as you have the memory. And at the end, it copies the name there. This is how it works. So each time it increases the space, copies the name, and keeps track of how many it had. When finished, if When done, if you have enough count, it sorts it. If you are very into algorithms, check this qsort. It's very cool. Remember, this is the sorting algorithm that most of OpenBSD tools and kernel is using. So it should be super good. And it's complicated. And then it goes, prints the first one. Very easy. You are on C. You cannot just join things. Prints the first one. Then, while there are still names, it prints space. Next one, if this is different than this one. So it won't print repeated names, and at the end goes to the new line and exits. Very easy to understand, very cool. Obviously you won't understand every single line of it, but you got the general idea. You can go deeper by yourself. And what is cooler? You can write your own. You have the man users. If you are on OpenBSD, download it. If you don't have, download it. Or on any Unix system you have, you still have this logic. It's enough to search for the format of UTMPX, find the size of each block, find where you can find the name, and write your own user. If your name is, I don't know, Sarah, go with S users. Users, and it's very fun, users. And you have your own Unix command with Python or whatever. Just parse this file. I repeat, if you are on a Unix machine other than OpenBSD, you have to search for UTMPX. Read the file, separate each block, find the name in the block, print them one by one. Some systems, like most of the Linux systems, like I think maybe Mac, if you have two Jody logins, if Jody is logging twice, it will write Jody twice. On OpenBSD, it writes it only once with this logic. Whenever it wants to print something, if the name equals the previous name, because it's sorted, it won't. If they are not equal, it prints it. But on a Linux machine I think I was trying on OpenSUSE, and on OpenSUSE it prints all the repeated names too. I know Jody logged in 5 times. Just a decision. You can do the same on your program. So write your own S users. It's not working anymore. It's dead. S users. Or whatever your name is, replaced. And have your own Unix command. Even you can go and write your own who. Writing it for production on different systems is more difficult because you are writing it for a very specific architecture on blah blah Linux with UTMPX file in this format, and your time is only 32. Your time never be 64 in this specific machine, and you can easily write it. If you want to write more general program which can be used on every system, you will have a more difficult time, but at least in the start you don't need it. Now you can write whatever command which was appeared in version 3 of the BSD, was there from the first Unix machines, and enjoy. If this was difficult for you, but you are still watching up to here, you can write another Unix command for yourself. There is a command called yes. It prints infinite Y's. Why? Because if you're doing something and it needs yes, 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 you can do yes pipe to that command, and it will answer yes to everything. Obviously, this is dangerous. Man, yes, you can get more information how it works. Appeared in version 7 AT&T Unix. Check that, the source of the yes, for example, on GNU, and you will see how complicated it is, because it should be able to compile and run everywhere. Anyway, have fun. Thank you for watching. If you're still watching, please subscribe, tell your friends. I will be happy to have more subscribers. I will have more energy to record more. Tell me if you liked it. We may be able even to go deeper and see who and where and how populates the UTMP file. That can be fun. To the next time.